Today, lesson 26B, day number 1 of exponential functions. So today we'll be solving problems involving things called growth and decay. We'll also discuss the differences between those two things and, as usual, our why am I learning this. Let's go ahead and get started. There are many things in the real world that grow faster as they grow larger or decrease slower as they get smaller. These types of situations are known as exponential growth or decay in the case of decreasing. And today, that's our focus on growth and decay. So let's start with problem number 1. Problem number 1 states, the number of people who have heard a rumor often grows exponentially. And in middle school, it's probably much worse than in any other level of the time that you spend in school. Rumors get started here and they get out of control in a hurry. So consider a rumor that starts with 3 people and where the number of people who have heard it doubles each day that it spreads. Why, for part A, why does it make sense that the number of people who have heard a rumor would grow exponentially? I want you to turn to your shoulder partner and discuss that for about 45 seconds. Why does it make sense that the number of people who have heard a rumor would grow exponentially? All right, so the reason is because the more people who know the rumor, the more people who will spread the rumor. And if it doubles each day, it doesn't take long for a lot of people to know what that rumor is. All right, part B. Fill in the table below for the number of people N who knew the rumor after it has spread a certain number of days D. So I told you that the rumor started with 3 people and then it doubles each day. So spend about 30 seconds completing your table. So here's our table. At day 0, that's the number of people who knew the rumor originally. That, of course, is 3. And then after that, it doubles each day. So at day 0, it was 3. If it doubled, day 1, that would be 6. And then it continues to double each day. So by day 5, 96 people now know that rumor when it started with 3 people. All right, so let's continue on with this problem. So this is problem number 2, but we're still dealing with the same situation here. We'd like to determine the number of people who know the rumor after 20 days. But to do that, we need to develop a formula to predict N, the number of people knowing the rumor, if we know D, the number of days it has been spreading. So what we're going to do here is we're going to sort of try and develop a pattern. And I started the pattern, the very basics of it, in your notes. So basically, here's what we have. At day 0, we know that 3 people know the rumor. And at day number 1, how many people know the rumor? 6. And to get that, it's basically the original 3 and then doubling that or multiplying it by 2. That's where we get the fact that 6 people know the rumor. And here's where you need to be adding on to the chart that I gave you. And don't just jump straight to the answer in. Let's fill in the 3 times 2 because it's going to help us develop a formula for the number of people who know the rumor. Now, day number 2, of course, if we look in our table, we know that 12 people knew the rumor. But how did we get to 12? Well, we get to the 12 by taking the previous day, which was 3 times 2. So I got this 3 times 2 from that right there. And then I doubled that or multiplied it by 2. So that's where I came up with the 12. And at day number 3, of course, that would be 3 times 2 times 2 times 2. So it doubles 3 times, and that's how we get 24. So I would like you to take the rest of that little chart there that we're starting and finish that off. Okay, so let me talk about one thing that I'm noticing as I'm walking around. Most of you are doing it exactly the way I've written it, but some of you have already seen what's really happening here. Like when I walked around, I saw a few of you for this one right here you wrote that as 3 times 2 squared. And then for this one right here, you wrote that as 3 times 2 cubed. And writing it that way gets you to what the formula really is much, much quicker, much, much faster. Okay? But the point I want to also make again is that to get day number 4, we know we're going to start with day number 3, and then we're going to double that or multiply it by 2. So that should look like this. That's where we get the 48. And then if I start with day number 4 to create day number 5, I'm then going to double that. So I'll take that and multiply by 2, and that's how we come up with the 96. But what we're trying to do here is we're trying to figure out some sort of equation, if you want to think of it that way, or some sort of formula. They both represent the same thing for any number of days based on 3 people knowing the rumor originally and then it doubling each day. So take a look at part B. Part B says, using the pattern that you developed in part A, write a formula giving the number of people who know the rumor N. If you know the number of days D, it has been spreading. So your formula has to involve the variables N and D. I want you to quickly turn to your shoulder partner and see if you guys can come up with a formula based on what we've done right here. As I was walking around, I saw most of you come up with kind of what we're looking for. So once again, part B, we're trying to figure out some sort of formula or function that represents what's happening here. Many of you wrote n equals 3 times 2 to the d power. That's a good formula. I'm going to write it as a function, though. So instead of me writing it that way, I'm going to write it like this. It represents exactly the same thing. I'm just writing it in function form. Okay? So once again, n of d is equal to 3 times 2 to the d power. Now, we needed that because now what we're looking for in part C is how many people would know the rumor after 20 days. So if we want to figure out how many people that would be, D is represented by 20 days. So what you need to figure out for part C is 3 times 2 to the 20th power. Now, we need to take a time out so we can figure out how to utilize these calculators as far as exponents go. Because I don't think you want to go 3 times 2 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 20 times. That takes a long time to do. Okay? All right. All right, so the question is, how many people would know the rumor after 20 days? And of course, in order to figure that out, we're finding n of 20. In other words, we're finding what 3 times 2 to the 20th power is. So Autumn, how many people would know the rumor after 20 days?
3,145,728 people.
Now remember, initially 3 people knew the rumor. Each day, the number of people who know the rumor doubles. After 28 days, or excuse me, after 20 days, 3,145,728 people know that rumor. When things spread exponentially, it doesn't take long for it to get really, really big. Okay? All right, let's go to part D. Exponential growth can be very fast. That's basically what I was just saying. Assuming our equation from part B holds, and I have it up here on the screen, how many days will it take the number of people knowing the rumor to surpass the population of the United States? And the population of the United States is about 315 million people. So here's what I want you to do. I want you to figure out how many days approximately it would take for everybody in the United States to know that rumor. I'm going to give you about a minute to 2 minutes by yourself, and then we'll compare what we have with our shoulder partner. Yeah, I saw several things happening here. I like the fact that a lot of you knew that n needed to be 315 million, so you set up an equation like this. And then that's where a few of you got stuck some of you realize that, well, I probably should divide by 3, and that's what you should do, because you really, before you can do anything else mathematically, you would need to get that part right there by itself. So let's go ahead and do that. Let's divide both sides by 3, and that would give us 105 million equals 2 to the d power. And then as I was walking around and you were talking with your shoulder partner, I heard some conversations about this. Well, I noticed the 2 to the 26th power was this, and I noticed the 2 to the 27th power gave me this. So you realize that it had to be somewhere between 26 days and 27 days. And in fact, it is. It's 26.6 days. So if you didn't get that, can you go ahead and fix it right now, please? All right, so let's now go to number 2 for the day. Helmut from Finland is heading towards a lighthouse in a very peculiar way. He starts 160 feet from the lighthouse. On his first trip, he walks half the distance to the lighthouse. On his next trip, he walks half of what is left. On each consecutive trip, he walks half of the distance he has left. We're going to model the distance d that Helmut has remaining to the lighthouse after n trips. So basically, we're kind of doing the same thing we did in the previous problem. We're going to set up a table and try and come up with a formula and so on. So let's go to part A. We're going to start with a table that looks like this. After 0 trips, how many feet was Helmut from the lighthouse? Say that again, please. Well, he's 160 feet from the lighthouse. Each trip, he basically cuts that distance in half. So after the first trip, how far is he from the lighthouse? 80. All right, finish off the table, please. All right, in about 15 seconds, I'm going to have you compare the table with your shoulder partner, and then with your shoulder partner, I want you to answer part B. In part B, it's saying each entry in the table could be found by multiplying the previous number by what number? Go. All right, let's finish off the table. Each trip, he cuts the distance in half. So obviously, on the second trip, it would cut that in half to make 40, and then 20, and then 10. Part B, it said, what number were we multiplying by? I heard some of you say a half. I heard some of you say 0.5. They are equivalent expressions. It doesn't matter which one. I prefer to think of it as 1/2 because it makes our formula look a little nicer when we deal with it in that respect. But it's the same thing. All right. Let's go to part C. Like in exercise 2A, we want to see this process by repeated multiplication by 1/2. So in other words, we're doing exactly the same thing we did in the very first problem, the rumor problem. So at 0 trips, Helmut was 160 feet from the lighthouse. And you should start filling in much like we did in the last one. The first trip, to find the distance, it's going to be the 160 times 1/2. And that's how we get the 80 feet. Second trip, we take basically what we had in the first trip, which is this right here, and then we're going to multiply that by 1/2. And that's how we get the 40 feet. And I want you to continue on through the next 2 trips. And then I want you to, for part D, try and come up with a formula. And based upon what we did in the first problem, the formula should be easy. All right, so the rest of this should look obviously like this. The third trip, 160 times 1/2 times 1/2 times 1/2, which is where we get the 20. And fourth trip, 160 times 1/2 times 1/2 times 1/2 times 1/2. That's where we get the 10. Then we need the formula, Spencer.
D equals 160 times 1/2 to the n power.
Yeah, and we really should, and once again, I'm going to write it as a function. We really should put the 1/2, since it's a fraction, in parentheses. I know I didn't do that in the first problem. The only reason I'm doing it is it looks a little nicer because we have a fraction to the nth power. All right, any questions about that formula? So now I'm going to have you do part E, part F, and part G on your own, and then we'll compare all three of those with our shoulder partner. Here's what you're trying to figure out. In part E, how far Helmut is from the windmill after 6 trips. Part F, how far he is after 10 trips. And then answer for part G, you're explaining why he will never reach the windmill. Go ahead and do part E, part F, part G, and then we will compare what we have with our shoulder partner. Part E, how far is he after 6 trips? Well, that would be 160 times 1/2 to the 6th power. When we're figuring that out, we need to follow the order of operations and deal with 1/2 to the 6th power first. Then take that and multiply by 160. That would give us 160 times 1/64, and that is 2.5 or 2.5 feet from the windmill. Part F, Helmut believes he will reach the windmill after 10 trips. Is he correct? Obviously it's no, but the reason is because when we figure out 160 times 1/2 to the 10th power, we end up with 0.15625 feet, which happens to be 1.875 inches. So while he is very close, he's not at the windmill. And then for part G, the question is, explain why Helmut will never reach the windmill. Well, it should be obvious that if we keep cutting the distance remaining in half, we'll never reach the windmill. We'll get extremely close, but never truly reach the windmill. All right, we're ending today with what we talked about. We talked about growth, and an example of that would be the rumor problem. Can you please fill that in? That's where the number of people knowing the rumor got huge very, very quickly. Our example for decay, of course, is the windmill problem, where we were cutting the distance in half each time. All right, we are finished for today. You have tonight's homework in front of you. Get your name on it. You may begin.